Yeah, g'day YouTubers. Tinker O'Toole again with another video. I had to do a modification. I had to make my own Morse taper to fit in the spindle because someone, for some unknown reason I don't know, before me, decided that they wanted to bore the inside of that. Instead of being 7/8, they bored it out an inch. Well, I had to take it out an inch and a little bit. I had to put a taper on there. I put a 1-degree taper on there. And I made it about 55 millimeters in length because they went in about 50 millimeters. No idea why they bored the spindle. But that just meant that I couldn't put a Morse Taper 3 in there. Anyway, it's taken me hours and hours and hours. I took an extra 1/2 mil off and I put a taper on there. And so if you actually look at the diameter of the spindle, the diameter of the spindle is 38 millimeters. So the hole that I bored was 25.75 at the small end, and at the big end was 27 millimeters. So it had about a 1.25 millimeter taper. Normally a taper is about 1.5 degrees. So I adjusted the compound slide and put it off to 1 degree from 90 degrees. So that gave me, it actually works quite good. So it sits in there with a nice taper. So it works well. So there's plenty of meat left on the spindle. So I've done the calculation that the spindle thickness, not including the thread, so excluding the thread, has got 5.6 millimeters of wall thickness. So if you add the thread, well, it's even thicker. So you got 38 millimeters down to 27. So there's 11 millimeters. And yeah, 11 millimeters plus 4 millimeters of thread because it's a 2 mil depth there. So if you go to 38 millimeters, take off 4 millimeters, you've got 34. So 34 versus 27. So look, it worked out good. Now, the other thing about making your own Morse taper is that you're going to have to really worry about runout. This is why it took me hours and hours and checking and backwards and forwards because, yeah, sure, I could go out and buy another spindle. You know, get one off eBay or whatever, AHM, whatever, go out and get another spindle. And I thought, well, how often am I going to use a dead center in the spindle? Not that often. So I don't have that function at the moment. I thought, well, look, if I stuff it up, I stuff it up and then I'll just go get another spindle. Now, luckily it came out fantastic because if I start the spindle, you can't even hardly see the gauge work. It's yeah, look, I really done a great job. So there it's running there. And if we zoom in, look at that. Can't even see the needle move. So I think a lot of people would be happy with that. So that's actually quite good. I don't want to leave it running there. You can see it's making a little mark already. Oh, it's only a little bit of oil. So that actually came up quite well. And what I will do is knock the spindle out, put the spindle back in and check for run out again. So I need to put the spindle in different positions. Well, there it is. That come up pretty good. Polished it up. I'm going to heat it up. So yeah, look, it really came up well. Now what I'm going to do is put it back in and we're going to check with the dial gauge just to see how good that came up. Okay, so if we turn the lathe on, look, I can't hardly see the needle move. That's how good that is. That's fantastic. The only thing that I had to do was when you push the Morse taper in, I need to give it a little bit of a tap. So this bar that I've got here has got a center in it, so I just put the bar on there and give it a slight little tap so that I don't damage the point. So, and yeah, I'll have to knock it out. So look, it came up probably better than I thought because I was worried about too much run out. Now, the scenario is at the moment, it's only, look, a couple of microns. That I can't see it with my eye hardly, I can barely see the needle. I'm sure that it is fluctuating a little bit, but if you can't hardly see it with your eye, there's virtually no movement. That's going to be okay if you want to turn between centers. That, to me, that's fairly accurate. So yeah. And if you really had something that was really expensive and you wanted to be very careful, it's just a matter of, look, you really need to, once you put something between the centers and you tighten it up, it pushes it in and it seats a little bit better. It was very difficult to get a smooth finish on the dead center, but essentially the dead center now becomes a live center because it's rotating. Now it's not hardened, so I'm going to try and just case harden it, so I may be able to get a little bit of success there, but it's not going to get much wear because it's going to rotate if I use it. So yeah, it's a dead center, but the dead center becomes a live center. Normally these things have to be specially hardened, but in this situation it's going to rotate around with the job because we'll put the plate and we'll use the dog with it, so that should come up quite well. Yeah, so all in all, the project came up quite well. So normally they have a Morse Taper 3. Why on earth someone would have slightly bored that out a little bit is beyond me, but they did. So that was the previous owner. I've turned it, I've got it well and truly within acceptable limits. So I think I've done a great job and I'm really happy with it. Thanks for watching. Bye for now.